Welcome to this video on the topic of vectors. In this lesson, we're going to have a look at how we can describe the relative length of a vector using the concept of a ratio. The relative size of vectors may be described by ratio. Consider, we have points A, B, and P, and they're all collinear. What we would like to do is we'd like to find the coordinates of point P such that point P divides vector AB in a ratio of 2 to 5. Now, looking at what this would look like as a diagram, let's bring our ruler up and let's explore. We would have a straight line, and the straight line would consist of points A and point B. Point A is located at -3 and 2. Point B is located at 5 and -1. Along this line, it's going to be divided by point P. Let's say point P is over here. And the way in which this is divided is that we have 2 parts down here, and we have 5 parts over here. We have a total of 7 parts. So the length of vector AB is composed of 7 equal parts, 2 of which are between A and P, and 5 of which are between P and B. So we break it into 7 equal parts. Now what we'd like to do is we'd like to find the coordinates of point P given this relationship over here. So let's have a go. Now using our diagram and the information that we plotted, let's try and figure out where point P is. Firstly, let's try and describe point P using the vector AP. We know that AP is going to look like this. Secondly, let's compare AP to the total length of AB. We know that there's going to be AB over here, and we know that AP is going to be a scalar multiple of vector AB. Now the scalar multiple itself is going to be bound by the parts and the total amount of parts we have. We have a total of 7 parts, and therefore we have 2 parts in length to describe AP relative to AB. So AB has been scaled by 2/7. This equation over here is going to reveal the location of point P. Moving along, firstly, we know that vector AP can be described as OP. Take away OA. Furthermore, OP is going to be equal to 2/7 of vector AB plus vector OA, because I can just add OA to both sides. Now, let's compute AB. Vector AB is going to be 2/7. Alright, it's at this point we don't mess around trying to do this by hands because we're likely to make a mistake. Rather, we say up we come to our calculators. And I'm simply going to simplify the expression on the right here. So I'm going to run matrix, may choose to clear my memory. And rather than putting the vectors in here, I'm going to do a different step today. I'm going to go into F4 for math. I'm then going to go into mathvec. I'm then going to type 2/7. I will pick a 2×1 vector, and I'll key in this vector over here, AB. Next one, and then I just execute it. This gives me the result, -5/7 and 8/7. So the position vector for point P is at -5/7 and 8/7. So therefore, point P is at -5/7, 8/7. So in summary, what we had to look at in this lesson was, we looked at how we can use vectors to describe the relative length of vectors to one another. This was showcased using the example over here, where we have 2 points in space, A and B, and we want to divide points A and B, or vectors A and B, using point P in such a way that we create a ratio of 2 to 5.